Hello, grade 12. We are back again with organic chemistry exam questions approach simplified part 2. And let's see the question that we got. So we have another question from September 2022, last year's prelim exam. I don't know from which province, probably Northwest or Mpumalanga, but it doesn't matter. If you know, you can comment on the section below. And then let's see, we're still going to approach it the same way. We use our method whereby we write the homologous series of each and every organic compound that we've been presented with. But before you can do that, let's check if we have a definition. Remember, you want to write out your definition or definitions as soon as you can remember them, right? So it's best that you write them first. So 2.2.1 says define the term functional isomer. Let's see what it is. Functional isomers are organic compounds that have the same general formula but belong in different homologous series and have different functional groups. So you will still remember cake whereby we said your carboxylic acid is a functional isomer to the ester and your aldehyde is a functional isomer to the ketone. Now, okay, let's approach the question now. So starting with our A from the suffix one, we can tell that it belongs in the alkyne group. And then B, looking at that molecular formula, we can see that there are only single bonds between the carbon atoms, which we know it belongs in the alkane since it only has carbon and hydrogen atoms. It's a hydrocarbon. Then C, that's C5H10O. Looking at this molecular formula, we can tell that it either belongs in the ketone homologous series or the aldehyde. So this corresponds to the general formula that we see there. So remember your ketone and aldehyde have the same general formula. Hence, we haven't confirmed where C belongs. Then D from that molecular formula, we can confirm that it is an alcohol. Remember the molecular formula that we said for alcohol, the CnH2n plus 2O. So you can see that it fits perfectly that we have 5 carbons, and then how many hydrogens? 2 times 5 plus 2 is 12. So that fits perfectly for alcohol. Then we have E, looking at where our double bond is. It's in the central carbon atom, meaning it's in between the carbon atom that is surrounded by other carbon atoms. So we can tell that this is a ketone. This is a ketone that is a carbonyl group. Functional group is carbonyl group. And then we have F. F is, let's see that, let me just erase here. So C, our C is C4H9OH. Now the OH is telling us that this is what? This is an alcohol. This is an alcohol. Nice. Now they're saying 2.1 for compound A, write down the general formula of the homologous series to which it belongs. So the general formula, remember we have identified the homologous series. We said it's alkyne. So if they're looking for the general formula, we know the general formula for the alkyne. So for 2.1.1, our general formula for alkynes is CnH2n minus 2. Awesome. Then for 2.1.2, it wants us to draw the structural formula of compound A. So we have 5-ethyl, 2,6-dimethyl, hept, 3-ine. So we want to start with the longest chain. Hept means 7 carbon atoms in the longest chain. So we have 7. Let's go. This is 1, 2, 3, 4, 5, 6, 7. Now let's look at where we have our substituents. We have 2, 6. So 2, 6. So let's start counting from this side. So if we start counting from this side here, our 2 is here. So we have methyl here, and then also in carbon 6, our methyl there. Then we have 5, so an ethyl group in carbon number 5. So this will be our carbon number 5, ethyl, 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 our ethyl. So hydrogen below here, I do not have. Okay, so you understand that that's a hydrogen. And then let's see what we got. We have the triple bond where we have the triple bond in carbon number 3. So counting carbon number 3, that's here. So triple bond, 1, 2, 3. So this is 1, 2, 3, 4, 5, 6, 7. Then we can just fill in the hydrogens where we need to. Then 1, 2, 3, fill it here. Then here it's already exhausted. For this one it's 1, 2, 3, 4, 1, 2, 3, 4, and then so we have another one here. So let's see, this is 2, 6. We have a methyl group in carbon number 2, and then we have another methyl group in carbon number 6. That's 2, 6 dimethyl. And we have so fill in the hydrogens. We are not done. Also here, wow. So we have that in carbon number, so we're 1, 2, 3, 4, 5. That's 5 ethyl. So our name is 5 ethyl 2, 6 dimethyl hept 3-ine. So I believe that's the structural formula. Hope you can see that. Now 2.2 says compound C. Compound C is a functional isomer of compound E. Compound C is a functional isomer of compound E. Now that confirms, if they say these are functional isomers, then this confirms, since we have E is a ketone, this confirms that C is obviously an aldehyde. Remember, our functional isomers is your aldehyde to ketone or your carboxylic acid to an ester. So here we have aldehyde to ketone. So if we are given that E is a ketone, that means C is obviously an aldehyde. Now they're saying define the term functional isomer. We've already done that. Then 2.2.2 says write down the IUPAC name of compound C, right? So compound C, how many carbons do we have? That's 5. So now since we know that C is aldehyde, we're just gonna go C is, the IUPAC name of C will be pentanal. Remember, there is no position for that formal group or that functional group. Then compound C is a tertiary alcohol. So let me erase here. Compound D is a tertiary alcohol, excuse me. Compound D is a tertiary alcohol. Write down the 2.3.1 name of the functional group of compound D. So now they're saying it's a tertiary alcohol. So what is the name of the functional group of an alcohol? We call it the hydroxyl group. The hydroxyl group. Now 2.3.2 says structural formula of compound D. Structural formula of compound D. We must also take the fact that it is a tertiary alcohol. So what is a tertiary alcohol? Is whereby the carbon with the hydroxyl group is surrounded by 3 other carbons. 3 other carbons. So how many carbons do we have for this alcohol? That's 5. So perfect. So we're gonna have it here. Let's say we have OH and then extending it here like that. So let's see how this is a tertiary alcohol. So now let's see the carbon with the OH, the carbon with the hydroxyl group. We can see that it is bonded to 3 other carbons. So this is a tertiary alcohol. So it still has 5 carbons, 1, 2, 3, 4, 5. So that's perfect. Now 2.4 says compound F reacts with propanoic acid. Now we said compound F is an alcohol. You will remember we wrote that compound F is an alcohol. Now compound F reacts with propanoic acid in an acid catalyzed reaction to produce a straight chain organic product. Now we know once we have a reaction of an alcohol and propanoic acid is a carboxylic acid. Now what comes to mind? An alcohol and in a carboxylic acid gives us an ester. So now they're saying 2.4.1, the general name given to this reaction. What is the reaction whereby we form an ester? We say that reaction is esterification. Esterification. Nice. Now 2.4.2 says write down the IUPAC name of the organic product. Write down the IUPAC name of the organic product. Now let's see what is taking place here. Now we are reacting this with propanoic acid, but now we want to first understand what alcohol is this one. So let's give the name of this alcohol. It has four carbon atoms. That means that's butanol. That's butanol. So that's butan 1-ol, because we know always it's primary alcohols that form esters. So that's butanol or butan 1-ol. Then plus propanoic acid. Propanoic acid. Now remember the name of the ester. We said we drop off this anol and we put YL for the alcohol, so it becomes butyl, right? So drop the anol and put YL, so it's butyl. Then from the propanoic acid, you drop off the anoic acid, you put OH, so it's propanoate. So the name of this organic product is butyl propanoate. Awesome. And that's how you could have murdered the question.